Excellent. Now we're familiar with RNNs, LSTMs, GRUs. Where can we go from there? Where can we improve now? Well, there is a great development on top of LSTMs, and these are bidirectional LSTMs. So we can actually write that in here as another option that we have to work with. So we have LSTM, and then we also now have a bidirectional LSTM. So bidirectional LSTMs have the same gated RNN structure as regular LSTMs, except that instead of running unidirectionally over the data, so just backwards through time and using previous time steps, previous words to predict the current state, bidirectional LSTMs run both ways. So that means that they can use information from the past and the future on a given state. In addition, that means that they can make use of both the beginning and the end of a document. So in our case, we have been biasing our models towards words near the ends of documents, but now with a bidirectional LSTM, we can be using information from the beginning of the document and the end of the review. So that's great. There's no reason why we shouldn't be using bidirectional LSTMs. They have been making a splash across natural language processing. I think for the most part, if you're getting going with a natural language processing task, you can start with bidirectional LSTMs. So let's have a look at how we implement a bidirectional LSTM in code. It's a little bit different than the Keras models that we've built so far. This involves a wrapper over our LSTM. I have, as always, created a notebook for you so you can follow along with this bidirectional LSTM notebook, or you're welcome to recreate it alongside me here by copying the vanilla LSTM demo. So let's give this a new name. Let's call it whatever, Bi LSTM demo. And we can rename the title. So bidirectional LSTM classifier. We're going to classify IMDb movie reviews by their sentiment with a bidirectional LSTM. Cool. So let's clear our output and start from scratch. So we are going to keep our dependencies largely the same. In fact, we're not going to take anything away. We can move our LSTM now into a row with all of these other layers that we're using, and we're going to import a wrapper. So there is a wrappers level below layers level, and we can use it to pull in our bidirectional wrapper. Everything else is the same. Our hyperparameters, we are going to change our directory name. So we can call this Bi LSTM. So we're writing the data somewhere new. And I found that I needed a few more epochs when I was running this just to be sure that our model wasn't going to learn anymore. So let's change the number of epochs up to 6. That should be enough. And another cool thing we can do here is now that we're reading our movie reviews in both directions, that means we can look over more of the review. And so instead of the gradient vanishing over 100 cells like we had if we were just looking back over the review, we can now have that gradient slowly vanish over 100 at the back of the review and 100 at the front of the review. So we can increase our maximum review length to 200. So increasing the amount of data that we have by that much is helpful in addition to using the great new architecture. Everything else stays the same. And then we load our data. We preprocess our data in the same way. And we do need to make a change to our network architecture. So we are now adding in the bidirectional wrapper. That's the only change. So in the LSTM layer row, we just add in bidirectional, and we wrap the LSTM in that. That's it. That's the only change. So let's execute that cell, and then look at the model summary. So that increased the number of parameters. So we went from about 1 million to 1.3 million. A big part of that is that the number of words that we're considering for each review went from 100 to 200. And yeah, model compilation is the same. Model training is the same, except that you'll notice training is quite a bit longer. So before we were looking at about 34 seconds per epoch. Now with this bidirectional LSTM, after it gets the data loaded in on the GPU, it's going to, on my machine, be 3 or 4 times longer, about 112 seconds per epoch. And we can have a quick look over at that in our NVIDIA SMI. So we can see things getting started here. Our GPU is running. Wattage is going up, and soon the temperature and fan will be going up too. Now we're not going to sit here and watch as our epochs train over the next 10 or 15 minutes. So let's pop in and have a look at the results. Have them out here. So head down to the bottom, and we can compare against the vanilla LSTM. So our vanilla LSTM, in its best epoch, it had 85.1% validation accuracy, and the bidirectional LSTM clearly edges that out. It has 87.1% accuracy, and our area under the curve went from the lower value, let's pull that up, from the vanilla LSTM. So we had 93% of the area under the curve for the vanilla LSTM, and in our bidirectional LSTM, it's 94%. So we're doing better across the board with the bidirectional LSTM. You may have noticed, however, that this still does not outperform the convolutional network that we tried quite some time ago. So the issue is to do with our data. So we talked about how the convolutional layer allows us to identify segments of, in our case, we had it set up so that we were looking for sequences of 3 words, where that sequence of 3 words is highly indicative of positive or negative review in our movies. With the LSTM, it's considering sequences of 100, and now with the bidirectional LSTM, 200 words. And so it's able to identify relationships that are more nuanced and over much greater distances than just 3 words, like the convolutional network. However, that kind of ability to notice nuance and learn these complexities of language is only possible with a very large data set. You can imagine that kind of 3-word combinations or single words that predict the overall sentiment of a review are relatively simple compared to nuanced language interpretations that occur, dozens or more words apart. So I'm confident that if we were using a much larger data set, as some of the ones that I showed you earlier in these live lessons, and you're welcome to pop those in here and detect the sentiment on those, for example, the sentiment on the Yelp reviews. And I think you will find that it performs much better with the bidirectional LSTM than the convolutional network. All in all, though, we're still doing great here. We've got 87% accuracy. We've got 94% of the area under the curve with this bidirectional LSTM. I've got a couple more tricks up my sleeve, though. Let's see if we can do even better.